Hi, welcome to my video on the sum and product of roots, part 1. When I do the sum and product of roots, I'm doing it on a quadratic, which is ax squared plus bx plus c. Done this in a previous video on quadratics. Check that out. The sum of the roots is negative b over a. The product of the roots is a c over a, so negative b over a and c over a. So we have an equation which is quadratic. X squared minus 4x plus 3 is quadratic because of the x squared. So a is 1, b is negative 4, c is 3. So the sum of the roots is negative b, so it's the negative of negative 4 over a, which is 1. So the sum of the roots is 4 over 1, or 4. The product of the roots, p, is c over a, so it's 3 over 1. So the product of the roots is 3. So just to illustrate that, let's factor this quadratic here. And x times x is x squared. Factors of 3 to give you, factors of 3 are 3 and 1. The product is positive and the sum is negative, which must be 2 negatives. So x minus 3 is equal to 0, or x minus 1 is equal to 0. X is 3, or x is 1. So notice the sum of the roots is 3 plus 1, which is 4. And sum of the roots, 4. Product of the roots is 3 times 1, which is 3. So notice you can find the roots and then add and multiply them. Or you can use negative b over a and c over a for the quadratic. And also here, look at this one. A is 2, b is 7, c is negative 4. So the sum is negative b. So b is 7. So it's the negative 7 over a. So the sum of the roots is negative 7 over 2. The product of the roots is c over a, so that's negative 4 over 2. C is negative 4, a is 2, so the product is negative 2. So to illustrate that again, I'm going to factor this trinomial, and 2x squared is made up of 2x and x. The factors of 4 are 4 and 1 and 2 and 2. But to get an 8, it has to be a 4 and a 1. So I'm going to put a 4 here and a 1 here and try it. 2 times 4 is 8, and 1, well, you subtract them. So the product is negative 4. So I have to have, product is negative 4, the sum is 7. So a plus 4 minus 1. And multiply. Plus 8 minus 1 plus 7. So 2x minus 1 equals 0. 2x equals 1, divide by 2, x is a half. X plus 4 is equal to 0, x is equal to negative 4. So the sum of the roots is a half, add on negative 4. So a half, negative 4 is negative 8 over 2, so that's negative 7 over 2. Common denominator is 2. And the product of roots is a half times 4. Product is, there's the two roots is a half and a negative 4, so the product is negative 2. Half of 4 is 2, half of a positive times negative is negative. So the sum is negative 7 over 2, and the product is 2. So that's, when you have an equation, you can find the sum and the products of the roots by using negative b over a and c over a for a quadratic. Now, let's do it different. Pause the video and see if you can work these out if you wish. Find the equation as ax squared plus bx plus c if the roots have a sum of negative 2 and a product of negative 8. Well, we know that the sum of the roots is a negative b over a. So that means if the sum is negative 2, that's a negative 2 over 1. So that means that a negative b over a is negative 2 over 1. So that means the negative b is negative 2. So multiply by negative 1, b is 2. and a is 1. So b is 2, a is 1. So the product of the roots is product, p for product, is c over a. So that means the product is negative 8, so it's negative 8 over 1. So c over a is negative 8 over 1. So c is negative 8, and a is 1. So notice a is 1 each time, which is what we want. There are times when a won't be the same here, so you've got to use equivalent fractions. So a is 1, so is x squared. A is 1, put a 1 here, so there's 1x squared. B is 2 plus 2x, and c is negative 8. So reversing it allows you to find the equation without going through. You can do it another way, but I'm just doing it this way. And number 2, the sum is 11 over 6, and the product is negative 5 over 3. Again, the sum is a negative b over a. So that's a negative b over a. The sum is 11 over 6. So that means negative b is equal to 11, and multiply by negative 1, b is a negative 11, and a is 6. The product of the roots is c over a, so that means c over a is equal to, c over a, I put 5 there then, c over a is a negative 5 over 3. So notice that, you notice that up here, a was 1 and a was 1, so everything was okay. But notice here, a is 6, and here a is 3. So we have to have the a the same. So if we want a is 6, we want a 6 here. So we take the 3 and multiply by 2 to get 6. So 2 times negative 5 is negative 10. Now c is negative 10, and a is 6. So a has to be the same value in the sum and the product. So a is 6, so 6x squared. B is negative 11x, and c is negative 10 equals 0. Again, the a's have to be the same value, so you make equivalent fractions with one of these to get the denominators the same. Okay, let's continue. So what about if we have an equation that's a, x to the n, b, x to the n minus 1, etc., up down to k, where this is the leading term of a, and this is the constant term of k. So the sum of the roots is negative b over a. But the product of the roots is k over a if it's even. That means if you have x squared, x to the 4th, x to the 6th, if they're even, it's k over a. Similar to a c over a, but because we have a cubic or a quartix or a quintix, then this last term here, we call it k. So if it's even, it's k over a. If it's odd degree, that means if this is a 1, a 3, or a 5, or a 7, then the product is a negative k over a for an odd degree. So let's illustrate that. And if you know what I'm talking about, then work these out. So this is a cubic. Cubic is an odd degree, so we're working like this. Sum makes no difference. So the sum is a negative b over a. So if we look at here, a is 1. B is negative 7. So it's the negative of a negative 7. So that's 7 over 1. So the sum of the roots of this cubic is 7. And the product, so that's the sum. And the product, because it's odd, which is 3, the product is a negative k over a. So k is the negative 8. So that's the k, that's the a, and that's the b. So k is negative 8, so it's the negative of a negative 8 all over a, which is 1. So that's 8 over 1, or 8. So the sum of the roots is 7. The product of the roots is 8. But again, repeat, if this is odd, it's a negative k over a. The sum is always negative b over a, no matter what your degree is. If it's a linear quadratic, cubic, quartics, quintics, makes no difference. The sum is always negative b over a. Now we have another one to do. So we have the sum is negative b over a, but we have to put the x squared term is missing, so I'll put the x squared term in because it's in descending order. X cubed, x squared, x constant. No, I got a 0x squared. So a is 1, b is 0, and k is 6. So the sum is negative b over a. So notice b is 0, so that's the negative of 0 over a is 1. So that becomes 0. Because b is 0 here, then the sum is 0. And the product is odd again. The product is a negative k over a. And so negative k, that's the negative, k is 6, so it's the negative of 6 over a, which is 1. So the product is negative 6. So the sum is 0, and the product is negative 6. Okay, let's continue. X to the fourth, x cubed, x squared, x constant is in descending order. We have an x to the fourth. So x to the fourth, we have a is 1, b is negative 2, and k is 12. Again, the sum is negative b over a, and that's b is negative 2, so it's the negative of a negative 2 over a, which is 1. So that's 2 over 1. So the sum of the roots is 2. The product, notice the degree is 4, is a quartix, so therefore it's just k over a. K is 12, it's 12 over a, which is 1. So the product of the roots is 12. So again, repeat, if it's even roots, it's k over a for the product. If it's odd roots, it's a negative k over a. And let's continue. Don't forget, pause the video and work these out. 4, 2, 1. Again, 3x to the fourth plus 0x cubed plus x squared plus 6x plus 4 in descending order. Notice a is 3, b is 0, k is 4. So the sum of the roots is negative b over a. So b is 0, so it's the negative of 0 over 3, so it's 0. The product of the roots, and this is the even power of 4, so it's 4, so it's just a k over a. K is 4 over a, which is 3. So the sum of the roots is 0. Product of the roots is 4 over 3. And we have to do number 5 and 6, and let's see. Got to be in descending order, so the highest power is 3, so it's a negative x cubed. Then it's a square plus 3x squared. Then it's a negative 6x minus 6. So descending order is x cubed, x squared, x constant. So a is negative 1, b is 3, c is negative 6. Oh, c. That's, I put c in when I'm talking about a quadratic. But when you talk about cubics, quintics, and that, I'm calling this last term k. Now, here we go. The sum is negative b over a. And so b is 3, so it's the negative of 3 over a, which is negative 1. So the sum is 3. The product, again, is odd. Because it's odd, it's a negative k over a. K is negative 6, so it's the negative of a negative 6 over a, which is negative 1. So that's 6 over a negative 1, which is negative 6. And the last one, again, we have to put it in descending order. Highest power is 4, so it's 2x to the 4 plus 3x. Now, notice I don't have an x cubed, so that's a 0. The x cubed is not here, so it's 0x cubed plus 2 plus, better be careful, and do the fourth power, then the cube, then the square. So it's 3x squared, then it's x, then it's the constant. Just be careful. Don't be like me. Sometimes I make those, what you call brain errors. So in descending order, the x cubed is missing. So a is 2, b is 0. We're going to put b is 0, but b is 0 there, and k is 8. Okay, so the sum is negative b over a. B is 0, so it's the negative of 0, just 0. A is 2, so the sum is 0. The product, and it's an even, so it's even, is k over a. K is 8. A is 2. So the product of the roots is 4. So that's doing the product and the sum of the roots. Again, for any polynomial equation, the sum of the roots is negative b over a. The product of the roots is k over a if it's even, like 2, 4, 6. And if it's odd, like x to the 1, x cubed, or x to the 1, x cubed, x to the 5, x to the 7, negative k over a. So that's a good way to find the sum and the product of the roots that I will use in the next video. So you have to know this for me to do the next video. Questions are going to be a little bit different and tougher. So that's part 1. And if you like my video, click the like button. If you're not a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope you enjoyed it, and hope you learned something if you didn't already know it. Bye-bye.